Good afternoon, everyone. I welcome you to IEEE sponsored FDP on recent tools for integration of smart systems. Our speaker for this session is Mr. Pankaj Salunkhe. We welcome you, sir, for this session on Introduction to Kingview SCADA. Before I hand over the session to sir, I would like to give a brief introduction about him. Sir has done his BE Electronics Engineering and ME in Digital Electronics. Currently, he is working as a manager technical department in Nimbus Technologies since 2018. Prior to that, he has worked as an HOD in ENTC department from 2008 to 2018. He has also worked as an assistant professor from 2001 to 2008. His expertise is in the area of PLC, SCADA, automation projects. Without further much delay, I would like to hand over the session to Sir. Over to you, sir.
Good afternoon to
Yes,
all
sir.
of you. Now, before
Good
we're
afternoon.
starting with SCADA, may I know how many of you know about the protocols which is used in industry? Because nowadays there are the most popular protocol used in industry is Modbus protocol. So I just a few slides show you some few slides regarding that because uh, without that we can't move forward. So you all of you know that automation, and right now in automation the Modicon is the first company which find out that protocol, and it is a free license to all. You can use it absolutely free of cost. So it is the most popular protocol used in nowadays in industry. Before 1985, most of the industry using that RS-232 protocol, that is recommended standard 232 protocol. You all of you know that DB9 connector, which is used in most of the uh, testing tools in laboratories. So that DB9 connector having the 9-pin connector. So the main disadvantage of this protocol is that you can connect only one device with the computer. So I just move forward. This is only slides which I use for the students. So what is protocol? It is just a set of rules. So for the communication between the device and the central processing unit, we generally use these protocols, and there are a number of protocols nowadays used in industry. One is the Modbus, second is the Profibus. Profibus is used where the sensitive signals are there. So most of the medical equipment using this Profibus protocol. Then third one is the CAN bus protocol. Most of the engines, the CAN bus protocol is nowadays used in automotive sectors. Uh, then J1939 protocol. It is a advanced version of the Canvas protocol, and it is used for the communication between the engine and CPU. Means to take the data from the most of the engines, we can use this protocol. Then EtherCAT, then IP, EtherCAT, then Ethernet IP, and there are a number of protocols which is used generally for the communication of the device and your central processing unit. So there are two types of communication generally, synchronous and synchronous communication. So I will not discuss about all these things because today I more focus on the SCADA. So duplex and hard duplex. Now I first give the introduction regarding this recommended standards 232 protocols. So there are recommended standards are nowadays for the communication between the device and your master is nothing but RS-232 protocol, RS-422 and RS-485. So how you communicate between this device, actual device, and uh, the PC. So in RS-232 protocols, which is introduced in 1960s, after that, it is very simple protocol. It is inexpensive to implement. It is a single-ended data transmission system. That is nothing but you can connect only one device through this communication wire. Okay, so it is a short distance up to 50 feet. You can use that wire. It's having the very slow data rate, that is 20 kbps, and maximum only one device you can connect it, and it requires nine wires. But in nowadays, if you are not using any head shaking signals, means only receive, transmit, and ground lines are used. Most of the industry use that machine uses only three wires: receive, transmit, and ground. So we can only use this RX, TX, and ground pin of this out of these nine wires nowadays. But it is a very it is very complications to run all these nine wires over the from the machine to the central processing unit, and because of that, it is not a most popular protocol. So they are discovered that a new protocol, that is RS422. This is a DB9 connector generally we are using, and out of that, only this RX, that is pin number 2, pin number 3, and pin number 5 are generally used for the machine communication if the handshaking signal is not required. Now 422 protocol. Now what is 422 protocols? Here it is also called as a 4-wire protocol, and it is that type of connection, that is parallel connection. So it is called a multi-drop wiring. It's that same pins are connected to each other and in parallelly, and out of that four wires, you can connect it to the host. A host is nothing but your central unit, a processing unit, where it gather all the data from all these devices. So it is a four. It is also called as a 4-wire protocol. Uh, it is used multi-drop network. Multi-drop is nothing but parallelly it is connected. Okay, so multiple device on a single data lines you can connect up to 10 device, 32. It shows that 32, but it is 10 device you can connect at a time. You can extend that wire up to 4,000 feet, and it is also called as a 4-wire protocol. This one, RS422. After that, it is also not nowadays not used in industry, so it is also outdated. So the next one is the RS485 protocol. It is also called as 2-wire protocol, and now it is a 2-wire protocol, and it is a use up to distance 4,000 feet. It having the data rate 10 Mbps, and maximum 32 device you can connect on a 2-wire, single 2 wires. Okay, so in this way you can connect the 32 devices, different devices having that RS485 output from that devices, and that 2 wires are connected to the host computer directly. And parallelly you can connect all these wires. Okay, that is a RS485 connections. uh, there's two multi-drop protocol. Multi-drop is nothing but a parallel connection. D plus and D minus of all the devices are connected to each other, and finally the 2 wires are connected to your host computer. So this is the energy meter. This is flow meter having the RS485 output. This is your proximity sensor. It also having that RS485 output. So all these three devices, you called it is slave, and is called that central unit is called as a master. So it is a master and slave protocol. So this is a comparison of all these three communication protocol, that is RS232, RS422, and RS485. So basically there are three protocols: Modbus, CAN bus, and Profibus. Nowadays it is, most of the industries focus on this all these three protocols. So very popular is nothing but your Modbus protocol, because it is a you can use it free of cost. No license are required for that. Okay, so this is a typical communication using that Modbus protocol. So in Modicon system in 1979 introduced these protocols for the machine to machine transmission. So, and all these three before that, all these three, RS232 and RS422 and RS485, the standards they have recommended to communicate between the host and devices. Device is nothing but your number of slaves. So how that communication art takes place, it is the master and slave communication. So master is always requesting the information from the slave. So whenever that master send the request to the slave, after that, that slave is responded to the master. Means after that, it gives the response. So we can say that in simple language, we can say that it is a request and response communication. So master is always requesting the information, and slave is always responding the information. So here, if you see in that, it is a RS485 standards I use to communicate between these all these three slaves, slave number 1, 2, and 3. If you see, whenever I communicating with this Modbus protocol, each and every device is identified by the unique slave ID 1, 2, 3. We can't repeat it again and again. Okay, so it is a RS485 communication. The green line is nothing but it is a request transfer from the master. Master is nothing but your computer, and red line is nothing but your response. That response is from the slave to the master. So one master can communicate with the 255. Practically, it is not possible to communicate with this 255 slave because there is a time delay. Error is occurred. Because of that, one master can communicate number of slaves and number of slaves transmitting the number of data at a time. So there is a issue of time delay, means time out. Some information may be lost. So generally, we are communicating up to 33 33 slave devices to the one master. Then each and every slave which is connected is having the unique slave ID. Then third one is the master can write the information to the slave also, or it can send the request to the slave, and then slave will be responding to that request. And Modbus is the open protocol. So there are a number of sub protocols or Modbus protocol are defined. Modbus on 232, Modbus on 422, Modbus on 485. I also say that RTU ASCII, that remote terminal unit, and ASCII, you all of you know that. These are the different sub protocols are there. You can also call it as a Modbus serial protocol. In serial, all these types are covered. So what is the slave ID? So each device which is connected, communicating, that host is communicating with the number of devices. That number of devices is called as a slave. And each slave ID, each slave has its own or unique slave ID in between 1 to 255. So master requests the data. The first byte which is sent in the slave address, it sends some request from the master. So in that master request, the very first byte which is it sent to that slave is nothing but slave address and used for the identification of that particular slave. Then second byte which that master say sent during that request is nothing but a function code. So I come to across this function code. After that, here the number of each and every device has its own memory. So there are two types of data in automation. One is the analog data, and second one is the digital data. So the analog data is nothing but uh, maybe in as per industry standard, we are recommended that analog data is in the form of voltage or maybe in the form of current. So there are some standards are mentioned in industry. So if the current is there, so current is always in the form of 4 to 20 milliamps or 0 to 20 milliamps. And if there is a voltage output from the sensors, so that voltage should be in between 0 to 5 volt, 0 to 10 volt, like that. So according to that, That analog and digital. Digital is, all of you know that digital is only zero or ones. Zero is nothing but your close, and one is nothing but your on. So there are discrete input. We can call it as a discrete input or analog inputs, which we take from the sensors. So in previous slide, where I show that one module is there, this one. Whenever that host is wants to communicate between the number of slave, at that time we require some remote data equation module. So that remote data equation module gather all this data from all this slave. So where it stored that data. So if the analog data is there are number of registers are given already in its memory. So that analog data is stored in two types of register. One is the holding register and second is the input register. So I come across these points also. And if the data is digital from the sensors or these slave modules, that data should be stored in coil register or contact register. The function code indicate which type of data that host can read or wants to read. That is defined by that function code. If the your host wants to read the digital data, so it read that coil or contact register. If the host wants to read the analog data, it may be read holding register or input register, like that. So that function code is mentioned in the request. So there are four types. See here, there are four types of register. Modbus registers are there. Coil register. So whenever the coil register are mentioned at that time, there is some identification for that register. So its address is always start with 0. This is the first, that MSB bit is always 0. And this is nothing but rest of the 4 bits is nothing but the address of that coil register. Second one is the contact register. So if you see here, the contact register is always start with this MSB bit is nothing but 1, and the rest of the 4 bit is nothing but your address of that contact register. The holding register. The holding register is, if you see here, it is always start with the 4, and its rest of the 4 byte is nothing but the address of that register. And the range of all these registers is up to 1 to 9999. Okay. So input register always start with the 3, and its addresses start from 1112 sorry 0012 999. So these first two register, coil register and contact register, these are the discrete register. And whatever the discrete information coming from the slave is stored in that register. For example, coil register, slave sends some 1 or 0 bits, so on or off status of that particular slave. So that status is right in this register. So coil register you can write from the master also, or you can read that register also. Means, for example, if I want to turn on something, so I can write in that register. If you read something, so I can read this register. So write and read property is assigned to this coil register. But contact register, it is not assigned to the contact register. Contact register, you can read only properties there. So coil register, you can read or write also, and in contact register, you just read that register. Similarly, for the analog data, so whatever the analog data which is read from that uh, slave slave side, you can store that data in these two register analog data, that is holding register and input register. If your central processing means your master wants to write something in slave module, so that register are used nothing but your holding register. So holding register having the both property, read as well as write, but input register doesn't have these two properties. It only having the read property. So we just summarize all this register, coil and contact register are discrete register. Out of that, coil register having the property read as well as write, contact register having the property only read. Holding register and input register both are used for the analog data. Okay, the holding register having the property read as well as write, but input register only having the read property. So how that register plays an important role in the model-based communication, see here. So it is a typical request sent from the master to the slave. Suppose here, this is a format of that one. Suppose that master wants to read some data, that is analog data, okay, from the slave. So how it send that request? So very first one, that is nothing but the 11, that is hex data. So the here, if you see the slave ID of this master, slave ID of this slave is 17. So hex of that 17 is nothing but a 1 1. So it mentioned the first byte is nothing but your slave ID. Next is the function code. We see here the function code for the reading the holding register is 3 in that table. So it mentioned that function code. So the slave uh, getting know that your master requesting to read holding register. So with how what is the range of that holding register? So it is mentioned in next 2 bytes, that is starting address of the holding register. So here the starting address is nothing but here 40108. So its base address is always 0. Yes, it start from 0 1 2 3 like that. So base is called 0. So that's why we take one bit, one address lesser than the this one. So if I want to read 40108, I take 40107 because base of this one is 0. It always start from 0. So 107, its hex is nothing but 006B. So the master wants to read these two registers which starting address is 108 and 109. These two addresses it want to read from this slave. So the whatever the data in the two register, it wants that data. Master wants this data. So it sends that request 00 and 6B to the slave. Next one is this two. How many register it wants to read? That is mentioned in next 2 bytes. So it is only two registers. So it mentioned 0002. Now here, this is the CRC, check redundancy code. It is generated from that master. When it transmit this frame towards that slave, after that reading this request from the master, slave responding another frame. See here in that, because what happened when that master communicate with a particular slave, it wants that slave ID first. So here it's just like a broadcast. There are a number of slave are connected on a single line. So out of that, it only the slave having this address slave address 11, it only accept that request. Other slave reject that request. And after that, the particular slave responding to your master. So it also that is a responding frame. So it when it responded to the master, it will send again the slave ID, function code, and number of bytes. So here these are the word registers. So it is having the 2 bytes. So the total 4 bytes it's sent. So it mentioned that 4 bytes. And what is the data? So data is in the form of hex. So 1232 is hex is 04D0. So it sent that D005 like that. These are that. And after that, this one is the CRC again. That is check redundancy code, which is generated by the slave itself. So in this way, there are types of communication means how that master requesting the information, how that slave is responding that to the information, and how that register or plays an important role in that all these things. So that is the basics of required to move forward for the SCADA. So I just, you all of you have these two software, that is ModScan and ModSim. So ModScan software is nothing but your master software, which read the data from the slave, and ModSim software is just like a slave, which responding to the master. So that's why I giving this two software for demonstration purpose. So I just give the introduction to these two software, because during the SCADA, we are using these two software as a slave. All of you are having that ModSim and Modbus setup. All of you are having that ModSim and ModScan software. These are used for the testing software. You can call it is. I just introduced that software. If you see here, that is ModScan. All of you visible all this my desktop. The desktop is visible to you.
Yes, sir. Yes, it is visible.
Okay.
Yes, sir. The softwares also we have it.
Uh, okay. Okay. So this is a ModScan software. So ModScan software is generally used to uh, read the response from the slave. So here, if you see that there's four types of register. We already observe here: coil register, input register, holding register, and this one coil and input status. Input status is nothing but the contact register. So these two first two are nothing but your uh, discrete register, and these two are nothing but your analog register. Okay, holding and input register. So holding having that two property, that is read as well as write property. Input register on the read property, input status register on the having the read property, and coil status register is having the both property, read as well as write. So I just show you that how you can read. And here you can mention that device id is nothing but the slave id, which slave data you can read from, that you mention over here. And this one is the starting address. Suppose for I want to read first 10 coil status, so I mention here 1 to 10, length is 10. Okay, so whenever I connect it, when I connect, we go to the connection connect. Okay, so here I mentioned that internal communication IP the 127.0.0.1, and its port is 502. When I mention it like this, at that time, see here, I'm not connecting any slave. So that's why it mentioned that model exception response from the slave device. Okay, right now I don't have any slave ID, slave. So for that, I use that ModSim software. I just minimize it and open the second software, that is ModSim. See here, I add one slave having the coil 10 register. Your slave is nothing but just like your the PLC, which I show in previous slide. See here, suppose your slave having this register, you just mention this register in that slave ID, mention the slave ID of your slave, mention the number of register. So I mention here 1 to 10 coil register I have in that slave. This slave device ID is nothing but a slave ID, and now connect to the port 502. Okay, so if you see here, when I generate one slave, the virtual slave with this software, I just disconnect and connect it. Open it again. Okay, one yes, started this match. Okay, there are two mod sims are already running on the same PC. That's it. So here, what I create one slave is generated over here using the modsing software. Okay, so suppose I that slave ID having the two channels, analog channels. That slave is nothing but just like your remote device. Okay, so as I change the length, see here, it will show me that invalid length or specific invalid response. I just again disconnect it and connect it again. So here it is this mod scan is nothing but your host device. Host device is nothing but your PC or any controller which read that number of slave. So see here, I change the value over here. It will reflect at the master side. Okay, like that. This is my slave and this is master. So if you see if you want to see that packets or traffic, which type of request that master sent, see here, this is a request which is sent from the master, this one. Stop it. So if you see here, 01 is nothing but a slave id, 03 is nothing but the its function code. It wants to read the holding register. If I change here, instead of holding register, I mention here coil. Okay, and connect it again. So here the function code get changed. It is 0. See here, it is 001 001. The function code get changed. It want to read the coil data. See here, if I change, see here, that coil is nothing but your on off switch, just like a on off switch or status of that particular device, whether it is on or whether it is off. Now if you see here that coil register, you can read that register from the master side, or you can write in that register also. From the master side, I can turn on it, so it get turned on slave side. So this coil register having the both property, read as well as write, means the master can write in that register also. Okay, but when I select that contact register, that is nothing but the input status register. So I can't write from the master side to that register. I can read only this register. Just I read this register from the master side. I can't write anything in that register. Suppose here from master side, I just double click on that, it can't get anything. But when I double click on that from the slave side, it can open that options. There is no option to write from the master side. So this register having only read property. Similarly, holding register. So if you see here, holding register having the both property. That is, you can write in that register from the master side also. See here, right now, the master read this holding register 222. Here I can read 222 on the master side, means your PC side. Okay, also I can write from the master side also into that register. See here, I can reflect it on the slave side also. So holding register having the both property, read as well as write, means you can read that register as well as write into that register. Input register. In input register, see here, when I change it, if you observe that first bit of all these addresses, input register addresses, it is always start from the 3. When I selected that holding register, it always start from the 4. Coil register will always start from the 0, and input contact register is always start from the 1. So in this way, we can read as well as write from these devices. The same thing has happened in remote devices. Means from the remote devices, when we connected or testing any remote IO module. Suppose that a remote IO module reads some sensor data, for example, 5000 or RTD or thermocouples. At that time, the data is in the form of 4 to 20 milliamps. So in 4 to 20 milliamps, you can get in that holding register or input register. Means that particular modules read that data in that register. It may be in holding register or it may be in input register. So we read that input and holding register on mod scan from this module. Okay, the mod sim software is generally used to giving the data. It's just used as a slave. Okay, so in SCADA we are using these both softwares. So generally we using this mod sim software to giving the data. Okay, you all of you clear these points?
Yes, sir.
Okay, any doubt in that? Okay, so I start with the SCADA. Any doubt? If you have any doubt, you can drop in a chat box also.
Sir,
Yeah.
sir, when you read some analog input, it will be stored in which register? How do we find out that?
Okay.
Whether in holding register or on, I think, input register, right? For
Yeah.
analog.
Yeah. Yes. Yes. It is
So,
depend on the manufacturer. Some manufacturer gives that data in the input register. Suppose what happen whenever we read that particular holding register or input register, there may be possibility to write something in the holding register. So most of the manufacturers giving that analog data in input register. Uh, you take the example of your RTD or PT100. So you all of you know that RTD is nothing but a resistive temperature transistor. Okay, so according to the change in temperature, its resistance increases or decreases. So, but we can't read that change in resistor. So how that automation or how that your sensing devices knows that whether that temperature is this one or temperature is that's one. So according to that, the manufacturers giving one table. What is the range of that RTD? It was first one, and that that RTD is connected to one temperature transmitter. The temperature transmitter is a function of the temperature transmitter is that it convert that change in resistor in the form of current. So as per industrial standard, we are using 4 to 20 milliamps or 0 to 20 milliamps. So 4 to 20 milliamps is nothing but 4 milliamps. It gives the output 4 milliamps. That is nothing but its lowest temperature. And 20 milliamps, it gives the 20 milliamps when the temperature is the highest temperature. For example, if I want to use that 0 to 400 degrees Celsius RTD, so whenever the temperature is 0 degrees Celsius, at that time it will give output 4 milliamps. And whenever that 400 degrees Celsius temperature is there, at that time it gives 20 milliamps output. So according to that, we can scale this particular temperature range. Now that range is, we are scaling that range, but the manufacturer means temperature transmitter stored that data in this register, maybe in holding register or maybe in input register. So here we can't write anything in RTD. So we just read that RTD temperature data. So that the manufacturer used as input register. Means the input register having the property that only read property. So the data is right in that input register, like that. For example, here I'm use the example. So for 0 degrees Celsius means for it will show that data like this 0000. And for example, if the temperature is 200 degrees Celsius, that is nothing but the half. So half is nothing but your 16 plus 8 plus 4 is 12. So the data, the output of that transmitter is 12,000, like that. It will use the output is equal to 12,000. It will not give like this 12.00. It will give the output 12,000. So in SCADA, we can scale this. It is divided by 1,000. We get it divided by 100 or 1,000, like that. That thing we can do in the SCADA. So SCADA, in SCADA, you can use read only this all these registers from the modules, different modules, data equation modules. All the sensors, all the actual connectors or all the on-off devices which is connected to that remote DI, remote modules, remote IO modules. Just I show you that what models are there. See here. This is one module that is TM82. It is analog module, two-channel analog module. So here, this is these two meter I show here. You consider it as a sensor. Sensor is nothing but your maybe PT100 or thermocouple like that, which gives the current output. So that current output I given to this means directly 4 to 20 milliamps. Whatever the milliamps is there, I connected this milliamps to this input module. That input module convert means write that particular milliamps in input register, and after that writing it in input register, that convert in RS485 communication. So RS485 communication uses this two wire, that is D plus and D minus. So I connect that D plus D minus to the converter, and this is a converter which convert that RS485 to TCP, and that TCP is directly connected to your PC. And in SCADA I can read these two register. So this is the way of communication takes place in industry. So
Okay,
instead
so
of this,
yes.
yeah, instead of this analog device, we can use for the digital inputs. We use that different device, which having that DIDO inputs over here. So whenever that DIDO inputs is there, means digital input and digital output. So we can use the different modules, which write uh, which write the data in the coil or in the contact register, and that register are read through the RS485 interface from this module. Okay, so this
Yes.
module is plays a very important role in we call it is that modules are the DAQ, that is data equation IO modules. See, these are PT100, and this is a temperature transmitter. This three wire PT100 sensor. Okay, so this device is called as a temperature transmitter, blue one. Okay, which convert that change in temperature, change in resistors into 4 to 20 milliamps, and that 4 to 20 milliamps is connected over here. So this is an example of that level sensor. Its output is 0 to 10 volt, so you can connect it to 0 to 10 volt. It is the voltage output. So that you, this is a wireless communication. So this RS485 interface is connected to GSM modem, and that GSM modem transmitted through GPRS communication. And at the receiving end, we can receive that data from the static IP, and it is given to the central location. There are different communication scheme. There are different modules. Data equation module and 8-channel analog module. This 8-channel DIDO module. So here it is having the Ethernet interface. You can directly check that status of this DI and DO directly through the Ethernet interface on the SCADA. Like that.
Okay, so thank you, sir.
So how you check that status on the SCADA? Before that, I just demonstrated that practical scenario of this, how we read the data from the remote devices. These are the remote devices. That module is connected with that sensor or that devices, and only the two wires are run over the field. That two wires, through these two wires, we can get the data of all these devices. Okay. Also, we can over the internet, if you have the static IP at your location, So we can ping that IP from anywhere in the world if your IP is static IP. So you can connect this like this also, that scheme. In that scheme, you directly turn on and turn off that device, particular devices from anywhere from the world. Radio frequency communication, that is RF radio communication. Its frequency is in megahertz for 33 megahertz. It is for short distance communication. If you see here that RS-232 and RS-485 devices are connected, its data is communicated. That modules are the pair modules. At one location, we can connect that point-to-point communication. We are using this RFU or Cambium, like that. Simple example of that industrial sensor, that is carbon dioxide, to measure the carbon dioxide, light intensity, all these things. Okay, just practical point of view, I show you all these things, how that data is coming, because virtually we are creating this module modsim. This module is modsim and this module is modscan, like that. This one, this is modsim. We are giving the data for this slave using the modsim software, and we can read the data of all this slave at modscan side. Modscan side is nothing but this one, SCADA side or PLC side. Okay, so this two, there are two testing software we are using generally. This modsim creating that slaves, number of slave. If you want to create the new slave again, you can having the different slave ID, that is two, having the two holding register, like that. You can create the number of slave having the different slave ID. See here, one is of coil, second is for input, third one is for holding, and fourth one is for this, the input register. Input register, it's starting at this one. See here, I connected this four slave. Now how you read that slave on the mod scan? This is a mod sim software. Mod scan. Now mod scan, in mod scan you can read all this register. See here. One slave ID one. What is here? To slave ID one, there is two contacts register. So in slave ID one, I show that contact register. Okay, coil register. Then slave ID 2, slave ID 2 is for two input status register are there. So I read that two status register in mod scan. See here. Then slave ID 3 is also having this two holding register. So I read this holding register. 1, 2, 3, and 4 is having the slave ID 4 with having two input register. So I also mention that. Get it? See here, this is mod same software. So I change that status over here and make it on. Update here and make it both are on. So input status is nothing but your DI. You just read it. We can't write from the master side. Okay. So here, if you see here, the status are get changed. So from here we can't write anything. See here, I double click on that. There is no window pop up over here. But whenever the coil register is nothing but if you want to turn on or turn off something at a remote site. So you can write from here also. Change the status of D also. See in mod same site, that status of that DO get changed. Okay. Holding register. We can write from the master side also because it having the both property, read as well as write. So I just write something from the master side. So whether it is reflected on the slave side also, or from slave side, I just write something. Suppose is a data. So whether it is, see here on mod scan, you can read that data. In input register, you just read it. We can't write anything from the master side. So for that, we are using this state. Okay. You clear all this concept, how to read, how to write the data.
Yes, sir.
Okay. So now we move towards that SCADA side. Let's close this software. So I just first I briefing all those towards Kingview SCADA. After that, we will move towards that actual practical demonstration of the Kingview SCADA. So the Kingview SCADA is having these three. We discuss about all these 3 points, 4 points. That is installation of Kingview SCADA. It is very simple. It is a license versions. If you don't have any license version, no doubt, no problem. It will once you install it, it will you can use that all the full functions of this Kingview SCADA for 2 hours. After that, it is you have to just turn off that application and turn out it again. You can use it again for the next 2 hours. So without license, you can use it for 2 hours continuously. Just you have to close it after 2 hours. So the basics of that Kingview SCADA.